Gpt-4o-mini Oracle takes in a question from you and searches Arxiv for dozens of papers to answer this question and gives you a final answer, a final long answer, a concise answer, and an opinionated answer for questions that may not have a strict answer. To be able to do this, it goes through several cycles of research. You can make it run it indefinitely, or you can specify how many cycles you want it to run. In each cycle, it goes through a query generation iteration in which it looks at the original question, in this case, best prompt to get an LLM to reason through complex problems, performs an initial analysis and a topic expansion phase, and then it creates initial queries to search Archive for with. And then it actually goes through a self-criticism and a refinement strategy phase, and then refines these queries. This happens in every cycle. And then it downloads each one of the papers and saves them. We saved the entire papers for this question. It downloaded and searched over 88 papers. Then it goes through a paper evaluation phase where it saves the title and the explanation for the title of the paper along with the URL. And it gives an explanation whether to actually look at that paper for its answer, meaning if it wants to research that paper. So it is going to accept some papers and reject some papers. So it evaluates the papers and gives an explanation. And then it goes through the Oracle analysis iteration. It actually generates knowledge from each of the papers and hypotheses from each one of the papers. We save these as well. And then it generates a final answer iteration using the key findings and the synthesized hypotheses. It gives itself a confidence score. It can stop when it reaches a confidence score that you have specified, or it can actually go on until the specified cycle number is fulfilled. It gives a long answer, and then a concise answer and an opinionated answer. This is to extract some kind of answer, even in cases where LLM might not want to answer or their clear answer is not available, such as the direct solution to the observer problem in quantum mechanics. As you can see in the final answer, we have an opinionated answer, which is much more of an answer rather than saying there is no single direct solution. Of course, always take the opinionated answer with a grain of salt because it's LLM generated, and there may not be an exact answer to your question. But all in all, it's a great way to research your burning questions. This one uses particularly Arxiv, but I built another O1 Oracle, which actually uses Perplexity for its search engine. You can find that at my YouTube channel as well. Code files for this will be available at my Patreon at the architect level. You can find a link in the description. So let's actually run it and see how it works. So it first asks you a research question. You can enter your question here. Let's ask when large language models will have infinite context. After that, it asks you the maximum number of iterations that you want to go through. Let's say default is 3. Let's actually stick with default and enter the confidence threshold. Default is 95, but you can input it as something like 99 or 100 if you really wanted a solid answer, or if you wanted to finish your iterations. Let's set it to 99. Now it asks you if you want the Oracle to have a consolidation step. The consolidation step summarizes and synthesizes information from all analyzed papers after each iteration. It helps to create a coherent understanding of the topic and reduces redundancy. However, it may also introduce bias and lose some details in the process. So what this means is you can actually default is yes, but you can say no, and I like to say no for more detailed answers. After each one of the paper evaluation iteration, and when Oracle analyzes each paper, it generates knowledge and hypotheses from each paper. If we choose yes to the consolidation step, then it will actually first form a consolidation of all the knowledge and hypotheses from all papers and generate an answer looking at the consolidated knowledge and hypotheses. If you answer no here, then it will actually look at the entire knowledge and hypotheses from all papers for answering. So I actually would like to say no here, but the decision is up to you. Like I said, the code is available at my Patreon. And when you download it, you can decide to choose it any way you like. And then we start iteration 1, and it's first going to generate and refine search queries. And then we will be able to see all the results accumulate under this folder. It is a nice organization method. And here we go. The query generation generated these. Let me zoom out so we can see better. It generated these search queries after actually rejecting some of them. And we also perform a filtration step where we make sure that we don't use the same papers twice. And it actually downloads the papers, saves them here, whichever ones it decided to use, and then it retrieves those papers, and then begins the in-depth analysis of 7 papers. Page of filtration evaluation summary, for examples, it evaluated 7 papers and accepted only 7 and rejected 43 papers. So this is what the query paper evaluation process is about. And then in the Oracle analysis, it creates the knowledge and hypotheses from the 7 papers that it accepted. And then it moves on to the second iteration after printing a confidence score, printing key findings and synthesized hypotheses, and then moves on. While we're waiting for this to finish, I would like to point out that if you're enjoying my videos, you can find all of my videos at my website, echohive.live, alongside of my YouTube channel. And if you do become a patron, you can actually download the source code for each one of them. Click on the link, and it'll take you to the appropriate link. For example, Fast Transcriber. Just click on it, and you can download the code. Each of the code file project files is attached to the post. You can also watch the videos for free at my website. Okay, we actually went ahead and started iteration number 3. Confidence increased to 90% after the second iteration. And I also would like to mention that after filtering, for example, here, one of the papers we had already downloaded. So when you're going through multiple iterations, it is useful to, not include the papers that we have already looked at. And all the process is written in JSON files here. The first answer in the first iteration, let's take a look, was that, let's look at the best guess exact answer. I've changed it from opinionated. It says infinite context processing is large language model projected to be achievable within the next few years. And we can take a look at the second final answer. It says that the large language models will not have infinite context capabilities imminently. However, advancements suggest that significant progress could enable effective infinite context within the next few years. As you can see, it has changed after looking at additional information and additional papers. We can actually compare these two. We can right-click by selecting both and compare selected. As you can see, the knowledge of key findings and the synthesized hypotheses have changed significantly, along with the answers that are generated from one cycle to the next. And here is the final answer. Let's compare it if it has changed significantly from the second iteration. And as you can see, it has. When you see that the answers are changing significantly, maybe you can run the same query with more cycles included. So we have finished running our entire research cycle. We do output total tokens usage, as you can see, along with how much this actually cost us. This entire process cost us 5 cents, and it's also written the file here as well. Let's look at the final answer. The concise answer, let's first look at this. It says large language models are progressing toward infinite context capabilities, but as of now, it remains theoretical goal not yet fully realized. Let's look at the best guess answer. Large language models currently have no true infinite context capability, but advancement in architectures could allow for effective infinite context within the next few years. So as you can see, this is very useful. I may make a few other videos exploring this more in depth. There's a README file, and requirements are listed over here as well. We will be reviewing the code, and it's quite a lot. It's actually 500 lines of code, and I'll do my best explaining it. But like I said, you can actually download it and use it right away from my Patreon. It's available at the Architect Plus level. And I have also these the mini Oracle search queries and mini Oracle paper eval. Like as I was building this, I kept track of the different stages. The full file is mini Oracle full. and this is the one we'll be reviewing, but the first and the second file will also be available at my Patreon as well. It makes it easier to follow through and see what is happening. We also use structured outputs from OpenAI. So let's get started with the code review. Before we begin the code review, I'd like to mention my 1000x masterclass. As you've seen, I actually built this mini oracle entirely in Cursor. Cursor is a new IDE which puts AI assistants first. And I think if you're serious about coding, you must definitely use it. And I actually built a course on it called 1000x Dev Masterclass. It has 23 chapters. Each one actually goes through a full complete project building, start to finish. You can watch the first chapter for free and preview each chapter for 2 minutes. It has projects built. In these videos, I build projects such as full stack apps, building a multimodal RAG system, Arxiv RAG Researcher, Grok chatbot. Some of the later projects is like how to build a full stack fast API web app builder. This web app actually builds web apps itself. How to build an codebase data scientist. And my latest one is actually how to build an how to build an O1 Oracle which performs long-range research, which was from my previous video. So the beautiful part of these videos is that I actually built each one of these apps from scratch. If you're interested, link will be down below, but there's also a link at my website, 1000x Masterclass. Now let's take a look at the code. Let's first overview the general principles behind this. We are first of all using structured outputs from OpenAI. Structured outputs guarantees the schema of the JSON output that you specify. It's much better than, more accurate than JSON mode or function calling. I like to use it with pydantic models. So we will be defining our pydantic models, such as when we are creating search queries, the query, the reasoning for this query, and a relevance score. So we define quite a lot of schemas here, but we will review this shortly. Let's actually see how our main script works so we actually get an overall idea of the operation of the script. First, we get user input. We're going to get a user question, max iteration, confidence threshold, and whether to use consolidation or not. Create all necessary directories. Then we're going to loop over and generate queries by using Gpt-4o-mini. And then we will, after that, use the consolidation knowledge step if we are using consolidation. Otherwise, we will process the queries, which will perform archive search, filtration, paper evaluation, and analysis. And then we update the process papers. And finally, we perform generate final answer step. So now let's go back to the top of the script and go line by line. We are using async OpenAI and creating a data class for token usage with prompt tokens, completion token, cache tokens, and total tokens. It is a method to update itself and calculate the price based on current pricing. We have a function to sanitize a file name, so we can use it to use it as a folder name or a file name. We have a function to create the run directory, which is going to be results directory. And we have a function to save the JSON, which is going to take a data, prefix, and directory. And it's going to actually enumerate and auto-number the files, such as 01, 02, 03. The iteration numbers are at the end. As you can see, this was the first cycle, it's the second cycle, and this is the third cycle. But each files is numbered as well, so you can better keep track of where in the process we are. Then we are defining the schemas for our model to use structured output. For example, the search query is going to include a query, which is the search query for archive, a reasoning, explanation of the thought process behind this query, and a relevance score, a self-evaluated relevance score for this. So now we have an archive search queries class. This is actually going to go over the initial search queries and expand upon them, or reject and keep some of them. This is where we take the search queries. So search query is defined here, and we are going to pass it as a list to the refined queries, and also for the initial query. So this archive search queries takes an original input, which is the user's original question. It performs an initial analysis, initial thoughts and analysis of the research topic, and then a topic expansion, exploration of related topics and potential research directions, but only with the goal of answering user question. And I will create the initial queries, the list of initial queries, self-criticism, critical evaluation of initial queries and approach, and then a refinement strategy for refining and improving the queries, and then the refined queries, list of refined search queries, and a final reflection, just in case if you needed it. And we have a paper evaluation schema, which is going to be the title of the paper, explanation for why this paper was selected, and a decision on whether to use the paper. So when we retrieve the papers, we don't just use them indiscriminately, but we ask the large language model whether if this paper is good or not for this particular question. And then we have the Oracle analysis, which is again going to include the paper title, and that is going to include generated knowledge, list of knowledge points generated from the paper, and hypotheses, list of hypotheses generated based on the paper, and a relevance score. Consolidated knowledge is going to include, if that step is selected, key findings, list of key findings from the paper, synthesized hypotheses, list of synthesized hypotheses, confidence score, answer, a detailed answer to the question, concise answer, concise and clear answer to the question, best guess exact answer. Actually, we do use this at every step. The naming is a bit confusing, perhaps. So consolidated knowledge is not associated with the consolidation step. My apologies. But here, where we define how to get the final answer, I guess I forgot to change the naming schema. But this is going to generate key findings and synthesize hypotheses from everything it knows, a confidence score, a detailed answer, a concise answer, and the best guessed exact answer, which is described as best guessed exact answer to the question without any vagueness or offering multiple options. This answer could be clear and direct answer to the question. Use your best judgment to give a clear and direct answer to the question, no vagueness or offering multiple options, right? Here's a function to remove the references from the papers when we're saving and using. So that part is irrelevant in my mind. And here's the get paper info, which is going to create a paper dictionary with all the information from the paper. We're going to try to download the PDF and then read all the pages and return the full text. Save paper to file. This is going to create a subdirectory for papers if it doesn't exist, and actually write the information for that paper just like this, with the title, URL, authors, and the summary, plus the full text, as you can see. And we have the Oracle mini analysis function, which is going to take the paper info, original question, and token usage. The system message for this is you are an Oracle AI tasked with analyzing research papers in depth, generate knowledge and hypotheses based solely on the paper's content, use your own knowledge only for reasoning and evaluation. So we would like answers to be generated based only on the papers. Here we take the user message, going to be the original question, the paper title, paper summary with the full text, and now we're going to say analyze this paper in depth, generate knowledge points and hypotheses relevant to the original question. And when we're calling the GPT-4o-mini, and feel free to change this to GPT-4o, unfortunately the all-one models don't have structured output enabled. But attention that because we are using structured outputs, we are calling the beta.chat completions endpoint with .parse argument. And here is where we pass our Pydantic data class, or the schema, Oracle analysis. As you can see, if we go back to the top, this is Oracle analysis is what we pass to it. So this is going to return token usage. If there is any bad request or something, contact length exceeded, fall back to using only the summary. So if for any reason, the paper is too long, sometimes it can be, and it doesn't fit into 128K context, and we just do the exact same call, only with the paper summary, okay? Consolidate knowledge, this is where we actually perform the consolidation step. The system message for, say, it takes an old analysis, original question. It says you're an Oracle AI tasked with consolidating, updating your knowledge from multiple paper analysis. So this only happens if you say yes to the consolidation step. Synthesize the information to answer the original question, gather all new knowledge, which may help answer the original question, update the knowledge and hypotheses as new information is found. We have attempt consolidation step, We get all the analysis as a dictionary, and then convert previous results to serializable format since they are in JSON. And here's the user message with the original question, current paper analysis, previous iteration, consolidate and update your knowledge, both from current and previous analysis. Okay, and then we call the GPT with consolidate knowledge, Pydantic schema, and start with all analysis and gradually reduce if necessary. Here we attempt consolidation. And this is the function to get the user input. We get a question, max iteration, confidence threshold, and here we print information on the consolidation step, whether to use consolidation or not. And then this returns all the whatever is needed. This is the function to search archive. It just returns the results. And here is the evaluate paper function. It's going to take in the paper, original query. You are an AI assistant evaluating research papers, determine if the paper is relevant to the original query. And here's the user message. We pass the original query, the paper title, paper summary, only the paper summary. And then we ask, is this paper relevant? And should it be used to study the subject? Provide a brief explanation, then answer with a Boolean. And we pass the paper evaluation Pydantic schema to that. That's going to return an evaluation. And we have the process queries function, which is fetch and filter. We just use this to actually check if we have already used that paper. And we print how many papers remaining after that process. And we process all this by creating a new papers task list and using async.io.gather. So all this happens in parallel. And then here we also called evaluate paper endpoint with async.io.gather. After the filtration, we also called evaluate paper all in parallel. And then we create an accepted papers and rejected papers list. And save paper evaluations to a JSON file, accepted papers with title, explanation, decision, and URL, and rejected papers. You can see these here in the paper evaluation, accepted papers with all their information, and the rejected papers. Rejected papers are here. And you can read the reasoning for each one. And we save the evaluation file, retrieving, and then we retrieve the paper info and save the files in parallel, again using async.io. Get paper info is called all in parallel. And then we analyze papers in parallel, again with async.io, Oracle mini analysis. And then we save the Oracle analysis again, using save to JSON. And here is the function to generate final answer. You are an Oracle AI tasked with synthesizing information from multiple paper analyses. Generate a comprehensive answer to the original user question based on all the analysis provided. You create a Oracle analysis object to dictionaries. And here's the user message. We pass the paper analysis dictionary and generate a detailed answer to the original question based on all these analyses. Also provide a concise answer and confidence score. This is what we use for that consolidated knowledge at the end. So we use this both for consolidation phase plus the final answer generation phase. And here in the main loop, we get all the necessary user input. We initialize all the necessary dictionaries. And now however many iterations has been specified, we start the iteration for that. And we have the generate queries call over here. So this is separate than all the rest of the API calls. This is the query generation prompt. You are an AI assistant specialized in generating high-quality search queries for Arxiv. Your task is to take a user research topic and generate up to 10 initial search queries, then refine and follow these steps. Initial analysis, topic expansion, initial query formulation, self-criticism and evaluation, refinement strategy, final query generation. So this is explained both in this message, also in the Pydantic schema, as we have seen. Provide detailed thoughts for each step and conduct thorough self-evaluation to ensure the queries are relevant and effective for archive searches. Include a final reflection on the entire process. Original question. You pass in the previous queries. If it'll be empty if it's the first step. And then we ask it to generate. And then we serialize the previous results. If available, then we call the archive search queries to Gpt-4o-mini. And at every step of the way, we update the token usage. And then we save to JSON these results, search, evaluate papers, and retrieve full text and analyze. Again, we await process queries function, and then we print all necessary information and update the process papers that are set, combine new analyses with previous ones. If we set consolidation phase, then we perform consolidate knowledge, save that to file, and I serialize the analysis and appended, print necessary information, and then save the iteration answer, whether consolidated or not. We save it, and then print all necessary information. And final output in statistics happens here. We generate a final answer and save it to file, print all necessary information. Usage info dictionary is generated here, and we save that to file. And files generated in this run, we also print each of the files that are generated, just as you can see at the very end, I believe here. So this is it. I know this was pretty complex. I'll try to make more videos on this and try to improve it as well. Like I said, this you can download this and use it right away from my Patreon from the architect level. If you enjoy my videos, you can find and watch all my videos from my website, acquive.live. There's a nice and convenient search box. You can just scroll through it and see if there's anything you're interested in. This Globe Explorer is very interesting. It uses Grok API to display information about cities all around the world. If you're a patron and would like to become one, know that you can just click on the download code from my website and immediately download source code to any one of my projects. And yeah, this is it. I also have tiers on my Patreon if you want to talk to me one-on-one. If you needed help with your projects or just want to talk to me, check those out as well. And I'll see you in the next video.